Okay, folks, welcome to Matrices. If you've ever seen the movie The Matrix, not the same thing. We are not going into an alternate universe here. But if you have seen the movie, it's actually at the beginning where you see a real matrix. It's basically just a list of numbers, so you will hopefully know what I'm talking about in a sec. But just to start us off as a reminder of how eventually we're going to solve these a little bit faster using matrices. I'm going to have you do the warm-up, which is just solving the systems that are here. So pause the video for me. Make sure that you go through each option. The first one, my recommendation is just a little hint. I would actually solve for z first, because 3x equals z, because you can actually just add z to both sides. And that means every time you see a z, if you plug in a 3x, this will turn into a two-variable system very quickly. All right, so pause the video, try them out. All right, guys, hopefully you got 1, 2, 3 for the first one, and then 1/2, -3/2, and 1 for the second. It is okay to get fractions occasionally. They just shouldn't be like crazy fractions, okay? All right, so we're going to get into the basics of matrices. So the definition of a matrix is just an array of numbers. So how they usually write that is it looks like they're just in brackets. So an example would be like 1, 2, 3, 4. That'd be considered a square matrix because it has 2 rows and 2 columns. So a 2 by 2, a 3 by 3, 4 by 4, any of those would be square. You can also do rectangular matrices. So you could have like 1, 2, 3, 5, 8, 12. I'm just making up numbers here. The dimensions of matrices are based off of how many rows and how many columns you see. So for example, it's always going to be row by column, first of all. Row by column. Rows go horizontally and columns go vertically. So for the example I gave you, this has 2 rows and 1, 2, 3 columns. So this would be considered a 2 by 3 matrix. The first one, weirdly enough, is a 1 by 1 because you only see 1 row, 1 column. The second one, how many rows does it have? So if you look horizontally, it has 1 row because literally you only see 1 of those. By 1, 2, 3, 4 columns. So that's considered a 1 by 4. All right, the next one, try it out for me. In fact, try the next 3 and pause the video, see if you get what I get. All right, hopefully you got 2 by 2, 3 by 2, and 3 by 1. So just a reminder that this has 3 rows, 1 column, hence 3 by 1, okay? The other thing is just a little bit of notation here. They asked you what is term A21 in letter D. So if you look at matrix D, okay, A21 means row 2, column 1. So if you look at row 2, column 1, the position that intersects there is 2. So your answer would be 2. What if I asked you for A3, 2 in that same matrix? So row 3, column 2. Yep, the answer is 4. Row 3, column 2. There you go. Okay, so that's the notation for it. All right, augmented matrices are next. All right, so an augmented matrix just helps you get prepared for eventually when we solve matrices using, or systems using matrices. What you do is use the coefficients of each of those variables. And then coefficients of each variable. And then you plug them eventually into a calculator to solve because it's going to be a lot easier that way for us to do it. Again, I'm not going to make you do that. All I'm going to make you do is write the augmented matrix. So what that'll look like is what I usually do is actually list out what all the variables are first. So I say x plus 3y plus 0z, because we need to have a placeholder for those missing variables. And then the next one would be 0x minus 1, technically y, plus 4z equals -2. And then finally we have 1x plus 0y minus 5z equals 0. So then the augmented matrix is you literally just list out the coefficients. We do like a little dotted line here to just show the solutions. So the solutions have their own little column basically. So this is 9, -2, and 0, which I just stole from here. And then all you have to do is write the coefficients of the variables. So you'll see this is 1, 3, 0, because you have 1x, 3y, and 0 z's. So this column represents all the x's, then all the y's, then all the z's. Okay, so then we have 0, -1, and 4. I'll have you put in the last row. Yep, it's 1, 0, -5. And that, weirdly enough, is all you need to do for an augmented matrix. They also want the dimensions. So the dimensions here would be, this is a 3 by 4, which, just so you know, all 3 variable systems are going to be a 3 by 4 when you put them into an augmented matrix. A 2 by 2 system, so like a 2 variable system, would end up being a 2 by 3 because you would have 2 rows and 3 columns there. Alrighty, this is our last page of these notes for today, and then we're going to do the rest of them on next class. So hopefully pretty quick, but also if you have questions, if I'm going too fast, please let me know later, okay? All right, how you usually list out a matrix is with a letter. So I could say like matrix A is 0, 5, -3, and then you can manipulate that. So we're going to do some operations with matrices. They're pretty easy at first. Multiplication is a little harder, but we're going to get through that in next class. But you'll find that this is pretty straightforward at the beginning. Okay, so this says solve for A11, A12, A21, and A22 in the following matrix equation. So literally they're just saying, in the matrix given, what are these answers? So A11 would be first row, first column is 2. Okay, they're just having you like solve. So hopefully you can see that in this place is a 2. So A12 would be -1. You can just look at the positions if that helps. A21 is going to be -3, and then A22 is going to be 0. So that's called the equality matrix because you're just like solving for that. The nice thing about addition and subtraction of matrices, all you need to know is they have to have the same dimensions in order for you to add or subtract them. Okay, so just be careful. These are both 2 by 2s, so you're good to go to add them. And all you have to do to add them is add each part. So 1 and -1 gives you 0. 2 and 3, so they're in the same position, give you 5. 0 and -1 gives you -1. And the nice thing is I'm not going to make you show a lot of that math. They just showed it at the beginning because they want you to see how it works. But then 1 and 2 is 3. So you guys can do all these in your head, which is pretty nice. Eventually, after next week, I'll show you how to do them in the calc. Ooh. Excuse me. Okay. Same thing, these are both 3 by 1s. So you can add them together, which means 1 and -1 is 0. -3 and 3 is 0. -2 and 2 is 0. So that's your final matrix. All right. I want you to take a look at C and tell me why you cannot add them together. That's right, because they are not matching. So you cannot. You could say NA, no solution. Any of the above will work because this is a 2 by 3 and the next one is a 2 by 2. So they don't have matching dimensions, so you cannot add them. Because it would be like you're trying to add 2 and 0, 1 and 1, but then what would 0 add to? So you can't do that, okay? I'll have you try letter D, so pause the video and see what you get. All right, guys, so hopefully you got for your matrix, let's see, should be a 2 by 2, right? Because these are both 2 by 2. So you get 6, -2, 2, and 3 as your matrix. Hopefully you're good there. The last thing we're going to do is scalar multiplication, much easier than regular multiplication for matrices. Unfortunately, with matrix multiplication, you can't just multiply the parts. So we're going to go through that next class. But if they want you to find 3a, what do you think they want you to do with all of the values in a? That's right, just multiply them by 3. So literally take all of these, multiply them by 3, and your matrix would be 6, 6, 12, -9, 0, -3. Do the last row by yourself right now. That's right, you get 6, 3, 6. Sorry for that voice, it's weird. Okay, anyway, this is your matrix. And you're done with this for today. Again, guys, we'll do a big graphing calculator section after next week because I want you to do everything by hand first, and then we'll do some shortcuts. Have a great day.